Welcome to Lead Programmer. Today we are going to look at the problem valid anagram. So essentially we have been given two strings and we have to return true if T is an anagram of S. And essentially anagram is a word formed by rearranging the letters of the different words, typically using the original letters. So for example, these two are anagrams because the first word S has A N A G R A M, and the second word also has anagram but rearranged in a different way. So we have N A G A R A M. So if you match these up, you would get that you'll find a pair for each and every letter as shown. Now, how do we solve it? So, one idea that we might get in mind would be okay, so why not keep track of which letter occurs and what its frequency is? So, if we can kind of have a table for our S, let's say we have a table for S which essentially has a mapping. A occurs three times. N occurs one time, G occurs one time, R occurs one time, M occurs one time. And then we have a table like this, and then we essentially look at T, and we see T is this. So we can start eliminating or reducing the frequency in our S table here. So let's see. Let's go through T. We have N, so we reduce the frequency of this to 0. We have A, so we reduce this frequency to 2. We have G, so we reduce the frequency of this to 0. We have A, so we reduce the frequency of this to 1. We have R, so we reduce the frequency of this to 0. We have A, so we reduce the frequency of this to 0. And we have M, so we reduce the frequency of this to 0. At the end, our aim is to see that everything, all the frequencies over here should be 0. Also, if we have a new character, let's say instead of M, we had Z. So Z does not exist in this table. And even in that case, we would have returned false, right? So we'll get a better idea of this once we look at the code. So let's go to the code. To start with, let's have our hash map as discussed. Let's name it letters of S. You can probably give a better name to this. So this is essentially the table that will have the frequencies of the letters. So now we go through all the letters in S, and if that letter already exists in our hash table, then we just want to increase the frequency of that letter by 1. Else, we want to create that record in our table and give it the frequency of 1. So if the letter does not exist, then we want to add the letter in the table, and its frequency would be 1. Awesome. So this was for creating our hash table. Next is for checking if T is an anagram of S. So to do that, we can go through all the elements or all the characters of the string T, and we see if that character is not in the table, then we know that is not an anagram, and we can return false right away. Else, we essentially want to decrease the frequency of that record by 1. And we also want to have a check to see if the frequency became negative as a result of that decrement. Because as long as the frequency is 0 or greater than 0, it's good, but it shouldn't be less than 0. It would imply that if S has 3 A's, T might have 4 A's, and in that case, it's not an anagram. So that check would help us over here. Awesome. So in that case, we also return false. In all other cases, we return true. Now, you might be thinking, what if the length of S and T are different? In that case, it will definitely not be an anagram. And you're right. So we need to check for that. So if the length of S is not equal to the length of T, then we return false. So the space complexity over here is basically the order of n, where n is the number of distinct letters in S. And in the worst case, our space complexity can be um, O of n, where n is 26, because there are 26 letters, and we have assumed that there are only lowercase English letters. What if we want a constant space complexity? How would we do that? One way to do that is to use a sorting algorithm and sort these in increasing or decreasing order of the alphabets, and then we can check for the equality of the strings. This is with the assumption that the sorting algorithm does not utilize extra space, or we ignore the space complexity of the sorting algorithm. So that's another way to solve this problem. I hope you enjoyed this. Please like the video, subscribe, and see you soon.